Why are GHZ states particularly suited for threshold protocols?
Great question. So there have been other approaches to performing quantum secret sharing as well that have been explored. And with each day, there are more and more solutions to performing secret sharing using quantum states that are being explored as well in the research domain. We have discussed today one of the first works that the original work that proposed the idea of quantum secret sharing and used GHZ states as an example. And GHZ states are particularly also applicable here because they're maximally entangled. And as we discussed just briefly, we need to really understand and get information regarding all the measurements of the different photons in the GHZ state, even if you want to reconstruct the measurement of one of the photons. All the rest of the photons have to be measured, and their outcomes are going to be needed to reconstruct the outcome of the first photon if one doesn't have access to that measurement outcome. So this is essentially from maximal entanglement that this property comes by. And one can potentially use other maximally entangled states to do this as well, and the protocol can be probably adapted around that. Additionally, there has been works that have explored using lower partite GHZ state, or what I want to say is for a three-party system, instead of using a tripartite GHZ state, you can use a bipartite two-photon entangled state. However, in this case, apart from distributing the two photons to the two players, the dealer can leverages the opportunity she has to switch the type of Bell state that she's going to distribute to the different to the players, and this gives her extra freedom that she doesn't have with respect to having that extra photon. Instead, she has this freedom to switch to a different type of state, and that is also encoding the secret message that she wants to be sharing with these two parties. So there are definitely so many more protocols that will be explored here, and today we are discussing this one around GHZ states. So.